Why is testing necessary? Well, software systems are actually an integral part of life. Most people have had an experience with software that did not work as expected. Software that does not work correctly can lead to many problems, including loss of money, loss of time, loss of business reputation, and injury or even death, as happens with car crashes and even more currently. Not all software systems carry the same level of risk, and not all problems have the same impact when they occur. A risk is something that has not happened yet, and it may never happen. It is a potential problem. Why does software fail? Software engineering remains a human intensive activity, and humans are fallible beings. Important factors that lead to failure might include time pressure, complex code, complexity of infrastructure, changing technologies, many system interactions. A human being can make an error, a mistake. The error produces a defect, a fault, a bug in the program code or in a document. If a defect in code is executed, the system may fail to do what it should do or do something it shouldn't, causing a failure. So there is a distinction between an error, a defect, and a failure. A defect can exist that will never cause a failure in actual use, because the conditions that could cause the failure can never arise. So, what causes software defects? In the first image, we commonly think of failures being the result of bugs in code. And as we can see in the image, a significant number of defects are introduced in work products such as requirements and design specifications. Reports indicate that defects introduced in requirements or design range from 45 to 70%. Ideally, defects should be removed in the same phase of the life cycle in which they are introduced. In the second image, we can see that if we wish to influence errors with testing, we need to begin testing as soon as possible, and as we begin making errors, right at the beginning of the development process, and we continue to testing until we are confident that there will be no serious system failures right up front, so right at the end of the development process. The extent to which defects are removed in the phase of introduction is called phase containment, and it is rather important because the cost of finding and removing a defect increases over time. And when that defect escapes to a later life cycle phase, it has multiplicative increases in cost of the sort seen in this figure. Quality cannot be defined by technical excellence alone. Testing plays an important supporting role in delivering quality software. Testing can actually give confidence in the quality of the software if it finds few or no defects. A properly designed test that passes reduces the overall level of risk in a system. How much testing is enough? There is a testing principle that says that exhaustive testing is impossible. Testing everything, all combinations of inputs and preconditions, is not feasible, except for trivial cases. Instead of exhaustive testing, risks and priorities are used to focus testing efforts. So let's take for instance this question. How many tests would be needed to exhaustively test a one-digit numeric field? What do you mean by testing exhaustively? There are 10 possible valid numeric values, but we need to make sure that all of the invalid values are rejected. There are 26 uppercase alpha characters, 26 lowercases, and at least 6 special and punctuation characters, a blank value. So there could be at least 68 tests for this small, simple example of a one-digit field. The software development process, like any other, must balance competing demands for resources. So, time, money, and quality are three resources that affect one another, and they also influence the features that are or are not included in the delivered software. Testing exhaustively, even if that is what customers and project managers ask for, is simply not what they can afford. Testing always involves trade offs. Instead of trying to find every possible test case, an impossible ideal, we should focus on what tests give us the greatest value by covering the most important parts of the system. Testing should provide sufficient information to stakeholders to make informed decisions. Deciding how much testing is enough should take into account the level of risk, project constraints such as time and budget.